Hello and welcome to the second module of Code at GWA. We hope you enjoyed the first one. If you have any feedback about the first one, feel free to shoot an email to either Jake or I. Again, our emails are in the description below, along with the overview document and the folder containing all the notebooks. So since this is Module 2, the notebook for this should be called Module 2. Speaking of Module 2, let's dive right in. So as the title says, we will be looking at handling inputs. More specifically, user input that's typed within the command line. So in order to do that within this notebook, we're going to first look at the input method, and we'll talk about how you can use it. And there are actually two ways to use it in your program. After that, we'll talk about different ways you can print various strings in the same method. We'll talk about single versus double quotes when making strings, and then we'll dive into some Boolean tests for strings, and then we'll do a little bit of formatting within strings, and then we'll talk about the in keyword, which is a Python specific operator. Okay, so let's start by getting by a way to gather input from the user. Here you can see we're just printing a line like we did in the previous notebook, but then we have a variable that's equal to a function or a method. Throughout the series, you'll be hearing Jacob and I refer to functions as methods and methods as functions. They're practically the same thing for what we're going to be doing, at least for modules 2 through 5. So yeah, you can use those interchangeably. We have a variable that's equal to a function, and then we're just printing a sentence, and then we're printing that variable. So let's look at how this works. And there's another thing with Google Colab. For you to run, it has to connect to their instance, so you just got to give it 5 seconds and then it connects. Okay, so this is what the input method actually outputs. It's a little text box where we can type whatever we want, and then that whatever we type, once we hit enter, that'll get stored as the small int variable. So let's actually put a small int in here. Let's put 12. Right, we hit enter. It says your small int is 12. Let's try this again with a different input. So let's put 146, and it outputs 146. So this brings us to task 1.1, which is basically storing an input within a variable. So as we can see in the directions, we have to create code to store an input in the student_name variable, and then we have to determine the type of that variable. So similarly, like above, all we do is we call, or we first have a variable, and then we set that equal to the input function like this. However, since we want to make the user aware of what they're typing, we should really ask a question. So in this case, I'll just print out what is your name. You can even put name, or you can even put name and then colon. Okay, so once we have this, we need to display the type. So for that, I'll just use print and then the type of the student name. And I'll just do one extra thing. This is not really required in the directions, but I'm just going to do it just to show you guys. I'm just going to print the actual variable that we get. All right, so just to recap in this, we're printing a sentence. We're asking the user for an input string. We're printing the type of that variable, and we're printing actually what the user said. So if we run this, let's say, what is your name? Let's put mine. Okay, this is one more thing with Google Colab. Sometimes your cursor does not appear in this text box. So if something like that happens, like what you just saw, just move your cursor down here and just type. Right, so Suraj. And then we can see that the type is a string, and the name, or whatever you inputted gets printed underneath because of this. Okay, so moving on to task 1.2. There's an important fact that's written here actually. So the input method always returns a string regardless of what you type. You can type in a number and it'll still return it as a string. You can type in a Boolean and it'll still return as a string. You can type in a string and it'll obviously still return as a string. So we're just going to investigate that a little bit here. Right? So first, Right, so first we have to get an input from the user. So let's call this test input equals input. However, we need to tell the user what we're asking. So I'm just going to do a quick little print statement. You don't have to do this because, I mean, you know what you're inputting, but I'll just put input like so. And then we'll test the type of this. So we'll just put type, and then we'll put the variable name in here, which is test input, sorry. So here you can notice that I use the type method just as is and not, you know, within the print method. And that's one nice thing about Jupyter Notebook. If you have a function that simply returns a value, you can actually place that function on the very bottom line, and whatever value that the function returns will be automatically printed to the console. However, this does have its caveats, as you'll notice. So we're going to give it an input. Let's give it a name. Let's give it John. This is just a simple string. Yep, so as predicted, it did say string. Going back to the caveat, here it says string. That's because we're just doing type and we don't have print. So yeah, this is just that one little thing. I mean, for all practical purpose, you know, they convey the same amount of, or they convey the same information. So I mean, it doesn't really matter. Okay, so continuing the song, like how the direction says, now we'll put in a number. Let's do 136. It still says string, right? So this is just to confirm that regardless of what you enter, it'll return a string. So this is another way to use the input, and actually I feel it's a more practical way to use the input method. So when I run this, you'll notice that the text box actually comes to the left of the text, unlike what we have done here, where the text box comes after the sentence. Oh, whoops, I have to. So unlike here where it comes underneath the sentence. So here it comes to the left. Okay, so let's see what this code does. So we're just going to put in a name. I'm just going to put my name, and it just says hi, and it uses this here. So this is just here to say that if you want an inline input, meaning that you want your question in the same line as your text field, you can use this. And I feel there's a more concise way to do it. Not only is the code better, also, you know, the user experience is slightly better because they're replying straight to the question instead of replying on another line. Okay, so this brings us to task 2. This is where we have to ask the user for their name, age, or their name, age, and if they want to be on an email list. So to do this, similar to above, we're going to create a variable called name, and then we're going to equal that to a function which is like this. So all that does is it prints this to the console, and then to the left of it, it puts a text field, and we're going to do this for name, age, and email list. That's our age, and that's our email list. Okay, so once we have these inputs, it's saying that we simply have to print it, right? So in order to do that, we're going to use the same string addition that you learned in the previous module. There are better ways to do this, and we'll get into that within this video, but for now I'll just use string addition, which is when you literally put a string and you put the mathematical plus symbol and you put the actual string variable. Right, so just to recap, it asks the user for what is your name, and it stores that within the name variable, and it does the same thing for age and if they want to receive emails or not. And then, like the direction says, it just prints them out. So let's try this out. So what is your name? Let's put my name, age, and if I want to receive, I'll say yes. There we go. Just like how the direction says, it prints it out to the console. Just to note, I used a colon here instead of an equal to sign. I mean, that really doesn't matter. I just wanted to point that out. Feel free to diverge slightly from the exact output you should receive, because, I mean, you know, like put your own spin on it, you know? Okay, so you can notice here that I used plus symbols, and I did say that there's a better way to do it, and this is it. It's called comma print formatting. In comma print formatting, what you do is, like the example says, instead of doing it like this with pluses, you put commas. And when I run this, you'll notice something. So this is just as expected. It just says, hello, John. However, if we look at the print formatting, the actual code for it, it says hello to, but there's no space. And then we have a comma, and then the string, and even in the string, there's no space. Again, here, there's no space. However, but when we look at the output, there are spaces. So basically what the comma formatting does is it automatically adds spaces, and this is a better way to do it because you don't have to account for spaces, and it's more readable. The code is more readable, and it's better. Okay, so task 3. Okay, so for task 3, we have to use a print function along with the comma separation formatting that I just talked about to combine 2 numbers and 2 strings. So you can just do something very simple like this. Just put a string in there, comma, a number. This could also be a variable, like you could do, num equals 17 and put num here instead of 17. And it'll give you the same output. However, just to keep things nice and concise, I'm not going to do that. So when we run this, we can see that it does run as expected and spaces are automatically inserted. Okay, for task 4, it's a little more involved. This is basically like an address generator. We ask the user for their street and street number, again using the input function, and then using the comma string formatting, we combine them together in one print statement and print it out to the user. So very similar to what we did up here, or at least the first part is very similar to what we did up there. So we're just going to do something like this to get their street and street number, and then to display a message, we're going to use the comma way. So it's going to be something like this. So we have our street number, comma, our street, because usually in addresses you have the number and then you have the street. So let's try this. So street, I don't know, let's put Flowerville Street. Number 1, 2, 3. So we can see it simply combines those two things. In the world of computer science, this is called string concatenation, if anyone's curious. Well, technically calling it addition is not really correct because it's not, mathematical addition, but I mean, we're not going to get bogged down with that. That was just a quick little fact. Okay, so moving on to task 5. It does look a little intimidating because of the large amount of text that's placed here and the long description, but it's actually quite simple. We just use what we learned up above here, and we just repeat that multiple times. And that actually brings me to a point of complexity of computer programs. First when you start a chunk of code, it may look very intimidating. However, you should always break it down into subsections, which then you analyze. Just to make it to seem easier and make it understand. Once we start working on big projects, you will have to start writing big blocks of code, and breaking those apart will help you. Okay, so coming back to task 5, it's basically a reservation generator or a reservation sort of input machine. We ask the user for the name of the contact person for the group. We ask how many participants are in the group. We ask what time they want to train, and then we print all this out in one neat line. One more thing, we do have one variable here that we also print out. So in order to do this, exactly like how we did it up, we just do something like that, right? We have a variable, and then we call the print function with the string in quotes, what we want to ask the user, and whatever they ask will be stored in this variable. One more thing, we need one more variable, right? So we need a variable called min early, And this is something that the users, that we're not going to let the users control, because if we sort of think like, like we're the administrators building the system, we obviously don't want to allow the user to decide how many minutes they have to come early. Right, so for this, we can actually pick any integer. So let's go with 8, because that seems like a reasonable amount of time for, someone to come early. And then we print it like this using the comma formatting. Right, so to do that, we can do something like this. Here we basically have, reminder, training, scheduled at, and then we have the training time, which is what the user inputs here. We have the owner, what the user inputs up there, and we have the number of people, which is what the user inputs up there. Just one note, you might have noticed this special character. What that does is that basically creates a new line. So it prints on a new line. And I'll show you this with and without. Right, so first let's check it out without. So for contact person, let's just put a name. Let's put Amy. Number of participants, let's put 7. Preferred time, 6 p.m. And as expected, we do get a string like this. However, this part looks a little ugly because because it's all like clustered in one giant block. So that's why I use this new line special character. And as you see, what this allows us to do is it can print on a new line. So let's just do this again. Oh, sorry about that. There we go, that looks much better. And in order to complete this, we have to add this very last line, which basically prints out the number of minutes that the person has to come early. So again, for that, we can use the comma string formatting method, something like that. So let's run this. And there we go. It neatly prints out how early that they have to arrive, and we can obviously change this to whatever we want, and that change will be reflected when this code block is run. Okay, so moving on, we'll be talking about when to use single quotes and when to use double quotes. About 80-85% of the time, it honestly doesn't matter. You'll be seeing Jacob and I using those interchangeably, just to emphasize the fact that it really doesn't matter. However, the only time that you will want to be using a certain style of quotes is if you want to include the other style of quotes within your string. Like, for example, if you want to include double quotes within your string, like let's say you're building a text-based game and there's conversation, you'll need double quotes for that. So in that case, you'll encapsulate your whole string in single quotes. And the same thing works in the opposite way for double quotes. So task 6 is pretty simple. We basically just have to demonstrate that. So this is an example of when you'll use single quotes. You can see here that there's a conversation that's happening. She replied, yada yada yada, and within this we have double quotes in the string. And if we run this, we can see that there are double quotes within here. Conversely, we have the way for single quotes within the string, something like that. Right, so just a quick little tidbit. I mean, again, like 85% of the time, it doesn't really matter. You can use them interchangeably. It only matters when you have a certain type of quote mark within your string. Okay, moving on to the extension. It being an extension, I'll only dive into one of these. Feel free to consult this notebook or the Python docs in order to learn more about Boolean string tests. However, the concept is pretty much the same. Right, so what a Boolean string test is it's a function that can be ran on a string in order to determine something. Like, for example, taking a look at this bottom one, if we do a certain string dot is upper, that function will return true if every single character within that string is uppercase. And If otherwise, it'll return false. Right, so let's try this out. So let's get an input from the user. Let's call this alpha test, and let's let's print the result of the Boolean string test. Right, so all we're doing here is we're getting an input and we're running the isUpper function on that in order to determine if all characters in that string are uppercase. So let's type in a string. Let's put QWERTY in all uppercase. Here you can see it returns true because every single character is uppercase. So let's try another case. Let's do code. It's false because it's all lowercase. And just one more, and just for good sake, let's do one where the first character is uppercase. Let's try a name. And here it's as expected false because you have these other characters which are lowercase. Right? Feel free to, while working on projects, feel free to consult back to this notebook or even the Python documentation. Because we don't have time to go through every single string test there is. Okay, so let's get started. You can see in front of you the platform we're going to be using. It's called Google Collaboratory, or Colab for short. That's how we're going to be calling it. And it's basically an extension of Google Drive's apps. So it's very similar to Google Docs, Sheets, and Slides. It has a very familiar UI. And yeah, it has the same things, things like share menus. Anyone with a Google account can access this. As you can see, I'm signed in with my GEMS provided one, but you can use it with any Google account. So this actually begs the first question: why are we using this platform over the traditional style of installing and configuring Python interpreters on a local system? Well, it's actually because it requires absolutely zero configuration. All we do is we open the Chrome browser, we navigate to this URL. As you can see, this is just my standard Chrome browser that I use every day. And it lets us experiment and code in Python 3. So we're not, fumbling with, interpreter configurations and all that. Secondly, it's very easy to share. This is very important because we believe in a very collaborative environment. So this will allow you to easily share this entire notebook with your peers or even us if you want, feedback to debug or anything. So let's get started. So this, stop. Fumbling with, it's very easy to share. Collaborative environment. So, moving along, we're going to finish off this notebook by quickly talking about the Boolean in keyword. So the in keyword is quite unique to Python, which allows you to basically search a large string for a given substring. And what this means can be demonstrated with an example, which is task 9.1, which is basically where we ask the user for an input who gives the name of a food item, and the program checks if that food item exists on the menu and returns a true or false Boolean back to the user. So in order to do this, first we're going to have to create a string for our menu. So this is basically mine. Just put a bunch of food items separated by a space. The space is very important in this context because that actually lets Python differentiate between substrings. And then we're going to ask the user what they would like. So again, we're going to use this simple input with the query argument like that. Okay, so now this is where the Boolean in keyword comes in. How this works is that we have a string and we put in, and then we have a larger string. So the initial string is a smaller one, which is what we want to check against the menu. So if you were to write it out, it would look something like this. So here we're just printing if whatever we ask from the user exists on the menu or not. The reason that we have the .lower method is because if you look at the very last direction, it should be able to ignore case mismatch. So since our menu, since in our menu all the food items are in lowercase, we basically sanitize the input by making it all lowercase. So in this case, regardless of if the user uses capital or small letters, we strip all that back to a lowercase, and then we check this lowercase string against our larger menu string. So let's give this a shot. So first, let's test out what does exist on the menu. Let's put fries in. So here it says true. So now let's test out something that does not exist on the menu. Let's put I don't know, pasta, for example. Now since this does not exist, it says false. Now let's test one unique situation. Let's try messing up the capitalization of a food item that exists. So let's put C capital, and then we'll just put O-O-K capital I, and then E capital. So here you can see I've typed in cookie, and this is something that does exist in the menu, but it's written in a different case. However, it still returns true because we're sanitizing that input using the lower function. Okay, so this brings us to task 9.2, which in fact is actually an extension activity. So if you're feeling highly inclined, please give that a shot. Okay, so we're going to finish this notebook off similar to the other one with a quick error fixing exercise. Here we're given a code snippet where similar to the menu string, we have paint colors. And then similar to what we did here, we're testing if a certain element exists in that string. So let's run this and figure out what is wrong with it. So here it gives us a name error, and this is what's really nice about Python. It explicitly tells you what went wrong. So here it's so here it should stand out that red, although it's written out the same way as this, it's not classified as a string by the compiler for Python. It's just interpreted as a standard variable name. However, we meant it to be a string. So all we can do is we surround this either by single or double quotes. I'll pick single quotes, just like that, and let's run this. And there we go. It returns true as expected because red does exist within the paint colors string. So that about wraps it up for module 2. We know this is quite heavy. However, this stuff is really powerful. If you can get acquainted with this, you'll be in great position for our next modules, which is all about functions.